Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 9. It says the graph of f of x is equals to 2x cubed plus 3x squared minus 12x is sketched below. A and B are the turning points of f, so the local maximum and the local minimum point. And then C2 is to 4 is a point on f. So as we can see it here, that's a point on f. Then 9.1 says determine the coordinates of A and B. But as we said, these are stationary points. These are stationary points. And then from our previous video, we've discussed that in order to calculate the coordinates of the stationary point, we must first start by deriving this to the first derivative. Then this is 6x squared plus 6x minus 12. But then we know that the gradient at the stationary point is equal to 0. So even if you were trying to draw a tangent that will be touching those points there, so say you draw a line like this and you draw another line like that, we know that once a straight line is parallel to the x-axis, the gradient of that straight line is equals to 0. Hence, we say that the gradient on the stationary point is equals to 0. So what are we going to do? We want to take that equation, that derivative equation, and then equate it to 0. So we want to say f prime x is equals to 0 at stationary points. At stationary points. And then this is how we calculate now. Say 6x squared plus 6x minus 12, and then that is equals to 0. Now looking at all these three terms, we can see that they are divisible by 6. So let's just divide throughout by 6 on the left hand side and also on the right hand side, and then we'll be left with x squared plus x, and then if we say 12 divided by 6, that's 2, and then 0 divided by 6 is still 0. Now we can factorize this, open two brackets like that, and then that's x, and then obviously here we must have positive 2 and negative 1 here, right? So looking at your middle term, we know that the bigger number must have the sign of the middle term. So that's just basic factorizing. And then here our x is equals to negative 2, or our x is equals to 1. Right. Now that we have our x coordinates, we have negative 2 here, and then right here we have positive 1, corresponding with our Cartesian plane, of course. And then remember, we are to calculate the coordinates, not only the x coordinates. So in order to find the y coordinates, what do? Remember, we must take this x coordinates and then substitute them back into the original equation, right? So do not forget, you do not substitute them into the derivative equation, because if you try to take these two values and substitute them here, what you're going to get is 0. Right. So it's only just going to tell you that the gradient at that point is equals to 0. But if you take it to the original equation, then you find the y coordinates at that point. So let's start with f when our x is negative 2. So that means we're just going to go into that equation and start to substitute negative 2 where there is x. Right. So I'm just going to replace negative 2 with x. Or replace x with negative 2. Then minus 12, that's negative 2. When you punch that into your calculator, you get your value as 20. So that means the coordinates that you have for A is negative 2 is 220. So the coordinates here would be negative 2 is 220. And then let's check when we substitute it into that same equation, but when we substitute the coordinate 1, so this is 2 and then 1 cube plus 3 and then 1 square minus 12 multiplied by 1. So when you punch that into your calculator, you get negative 7, right? So that means the coordinates for B are 1 is 2, negative 7. So we can see it's below the x-axis. So that point makes very much sense, right? Then, okay. So we have found our coordinates for both A and B, and that one was for 5 marks, right? Then 9.2 says, for which values of x will f be concave up? Will it be concave up? Now you will remember that I said if they ask you about the concavity always relates to your point of inflection. You will remember that I said that there is no concavity without the point of inflection. But how do we find the point of inflection? Already now you have the x coordinates of the turning point, which you had -2 here, and then here you had +1. We said that by just calculating the midpoint of this x coordinate here, calculating the axis of symmetry here, you can actually find your point of inflection. So you can just go x is equals to -2 plus 1 and then divided by 2. So it's like finding the midpoint of your what you call your turning point, right, or your stationary point. Then that's x is equals to, it's going to give us a -1/2, which might be somewhere here. So this is where your graph changes concavity. But then what are we looking for? We are looking for all the values of x for which it will be concave up, right? So if you are saying this is -1/2, what is concave up? We need to first understand when they say concave up, they are referring to the smiling graph. This is normally what you call the smiling graph, a shape like this, right? So where do we find our cubic function imitating the shape there? We can clearly see that it's after the point of inflection. So there we go with that shape. Remember, at the point of inflection, we say the graph is neither concave up or concave down. It's just it's the point where it starts to change the concavity. So it's changing from being concave down and then to being concave up. So when we write that one mathematical, we're going to say, therefore, the graph of f is concave up when x is greater than -1/2, right? That's just how you were supposed to go with that one. So maybe 2 marks for calculating the point of inflection and then a mark for then concluding that it is concave up after the point of inflection. Right. Now, others might choose to do it the longer way. There are actually 3 ways in which you can calculate the point of inflection, really. So at this point, you can even calculate your point of inflection by saying x is equals to -b/3a. Now that you do have the equation of the cubic graph, right? So you can say your b is the 3 there, and then now you have 3, and then your a is 2. Right, so this is going to give us -3/6, which is -1/2 as well. So you can still see that you have the same value. Another way to calculate it would be to derive this twice. So now you have already found the first derivative. It was 6x squared plus 6x and then -12. So here you had -12. So what you would do is you'd find the second derivative, because remember, second derivative is the one that we use in order to find the point of inflection. Then here would have 12x and then plus 6. But then what we need to do is to equate the second derivative to 0, because that's another form of stationary point. So this would end up giving us 12x is equals to -6 if we transpose it over to this side. If we divide both sides by 12, then our x is going to end up as -1/2. Right. So we had all those ways in which we would calculate the point of inflection. So either you take the coordinates here for the stationary point, the x coordinates of the stationary point, and calculate the midpoint. That becomes the point of inflection, or you just simply use this equation here for the axis of symmetry of the cubic function, or you just simply derive it twice, right? Okay, so let's proceed now. Let's go to 9.3. So 9.3 says determine the equation of the tangent to f at c 2:4. Now, whenever they mention tangent, right, there is one thing that you should always note, whenever they mention tangent, the most important thing to get is the gradient of the tangent. And then we know from this equation here that f prime x will tell us about the gradient of the tangent. So remember, f prime x, we call it as the gradient equation, right? Or the gradient graph, or the gradient function. So this is the gradient function. So that means it's reporting about the gradient. Now remember, a tangent is simply just a line that touches the curve at one point, right? So if we were to draw a line that will only touch one point here, and then crossing there, probably the line would look something like that. So let me use another color. Probably the line would look something like that. And then let's just pretend that it touches at that point only. So I'm trying to make it a tangent. So let's just pretend that it's touching only at that point. Okay. Seems like I'm failing to actually have a nice tangent there. So, okay. Let's say now we have our tangent touching the circle at that point there. And then this is what we're going to have. If we calculate the gradient of this function, or we calculate the gradient of f of x, the cubic graph, the curve, at this point, then we do understand that the gradient at this point will be equal to the gradient of the tangent, because remember, that's the point of contact, right? So the gradient of the cubic function at that particular point is equal to the gradient of the whole tangent. Remember, the tangent cannot be changing its gradient, because a tangent is only just a straight line. It has the same gradient throughout. But then with the curve, a curve has different gradient at different particular points, right? So we are saying that the gradient at that particular point of contact will be able to report to us what is the gradient of the tangent at that point of contact. So noting that, we will just say, okay, we already have the gradient function, or the gradient equation, which was 6x squared plus 6x then minus 12. Right. Now, in order to find the gradient of the tangent, let's first calculate the gradient of f prime x at that point, at 2, at the point of contact. So we're going to say f prime, and then when x is equals to 2. So this is 6. And then that means where there's x, I'm substituting 2, right? So note that I'm substituting in the gradient function because I want to find the gradient at that point. Then f prime when x is 2, I'm getting 24. So that means the gradient of the curve at this point is 24. But then, since the tangent is in contact with the curve at that same particular point, that means also the gradient of the tangent at that point is equals to 24. Now, this makes sense. Okay, so in order to find the equation of the tangent, which we know a tangent is a straight line, we would have to use this formula, y is equals to y1, and then mx minus x1. Or you can just go with the basic one, which is y is equals to mx plus c. Now with this one, you know that you have to first find the value of c, and then blah, 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 and then write it in that form. But then I prefer this one because all you just do is substitute your gradient and you substitute your coordinate. So that's y minus 4, and then your gradient is 24, and then that's x minus 2, and then this is going to give us y is equals to 24 times x, that's 24x, 24 times negative 2, that's negative 48. Then if we transpose the negative 4, that's positive 4. And then our equation is now 24x minus 44, right? So this becomes the equation of the tangent, right? So please play the video as many times as possible and try to understand the approach that I took into solving this question here. But then with all that being said, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.